Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Welcome. This is Mr. Simon, and we are here to change our world with chemistry. Today we are going to talk about alkanes, and it is actually organic what? Chemistry. So our lesson today is about naming alkanes. So by the end of this lesson, students should be able to name alkanes. So we should be able to give the names of what? Alkanes. So we can begin by talking about alkanes. Alkanes are actually part of our homologous series and part of our organic compounds. The general formula of alkanes is CnH2n plus what? 2. And they're actually saturated hydrocarbons. So these alkanes are, most of them naturally exist in things we use as fuels, like for example, paraffin. Actually, the other name for alkanes is paraffins. Then they exist also in petrol. We find them also in gas, the one we normally use for cooking, or we can call it natural gas. They also exist in petrol. They exist in diesel. So these are the natural sources of alkanes. So alkanes are very important if you talk about them acting as what? Fuels. So we are going to briefly talk about their naming. So nomenclature of alkanes. So there are basically two ways of naming alkanes. We have the new naming and the old naming. So the new naming is basically what we talk about. It may not be new. We can call it a systematic what? Naming, because these days it is no longer new as such. So it's a type of naming laid down by the International Union of Pure and Applied what? Chemistry. So we are going to talk about what we call the IUPAC system, or the systematic way of naming alkanes. So meaning this systematic way follows some rules. It follows some what? Rules. But when you are naming straight chain alkanes, they are given what we call trivial names or trivial names. Like for example, here, let's take an example. Here, we are going to name our alkanes from number 1 up to 20. Number 1 up to 20. But before, let's just make an illustration from what we actually covered in O level. So we are going to have a simple table here. Simple table. We're going to have a simple table here where we're going to put N. Remember, we've said our general formula is CnH2n plus what? Plus 2. So we say N, where N is the number of carbon atoms. Number of carbon atoms. So this is going to be our N. Then we talk about what we call the molecular formula. Molecular formula. Then we have what we call the structure of the straight chain. The structure. So we are going to use the semi-developed formula. And then we actually going to give these names. Not all of them, just a simple illustration. Simple what? Illustration. We have something like veg, and like words. Then we can say our names. So before we name them using rules, there are names we normally focus on. Like for example, here we have number 1. Number 1. Our number 1 will be CH4. And actually, the structure formula will also make it CH4. CH4. Then number 2, we shall have C2. So 2 times this times 2 plus 2 will be 6. So we shall have CH3 and CH what? 3. So number 3, we shall have C3. 3 times 2, that is 6 plus 2 will have what? 8. So we shall have CH2, CH3. Then we can also have number 4. So C4, H what? 2 times 4, 10. Plus 2, we shall have 10. So we shall have CH3, CH2, CH what? 2 and CH what? 3. Then we can also have 5, where we have C5. 5 times 2, 10, plus 2, we shall have 12. So we shall have CH what? CH3, CH2, CH2, CH what? 2. We have 5, 1, 2, 3, 4. Then you can also have 6 also. C6, 6 times 2, 12, plus 2, 14. So we have CH3, CH2, CH2, CH2. As I write here, at least you get something of what we are writing. So, yeah, that's what we have. So this is a simple illustration. You see, we are using these formulas here. We get them from what we call the general formula. The general formula. So remember, when you are defining homologous series, we say the series of compounds having the same general formula, method of preparation, but differ from one another by additional CH2 group, in addition to what we talked about. So, these are the names. The name of the first alkane, we shall call it methane. So you should get these names because it's what we are going to be using throughout our organic chemistry. The second one will be ethane. The third will be propane. Who can tell me number 4? Number 4 is the butane. Is what? Butane. Number 5, we shall call it pentane. Pentane. And number 6, hexane. Like that. So here, when you reach number 5, we basically, you can borrow the knowledge of mathematics, where we have pent meaning 5, hex meaning 6, hepta, octeta, octa, like that. So those are some of the examples of our straight chain alkanes. So we are going to look at more examples here. If you look at your screen, just look at your screen. You see we have stopped on number 4. So number 7, we shall call it heptane, or you can call it this name here, septane. Septane. Despite the fact that we have put S. So we have octane. We have octane. Octane is number 8. 8 carbon what? Atoms. We have nonane with 9 carbon atoms. From the word, you can call it nonagon. Then number 10, we shall call it decane with 10 carbon what? Atoms. Our system is still 10 times 2 plus 2. So we have 22 hydrogen what? Atoms. So from there, when you reach number 10, if you want to go to 11, we use, all of them are decanes. So, but this one we call it undecane, then dodecane or duodecane, then tridecane, tetradecane, pentadecane, hexadecane, where we have 16 carbon atoms. You have 16 times 2, which is 32, plus 2, which is 34. Then number 16 is the hexadecane. Number 17, heptadecane. Then number 18, octadecane. And number 19, nonadecane. And then we have number 20. We have number 20, icosane. or we can say icosane. Icosane. So we have, these are the names of our straight chain alkanes. Here we have tried to represent our structures in a simplified way, where we have the CH2s put together such that they can fit on our table, So quickly, we are going to talk about alkali groups. While we are naming these organic compounds, we need to talk about the alkali groups. Alkali groups are named by replacing N with YL and the corresponding name of what? Alkanes. And they are represented normally by R. So we remove, when you are naming, we remove that N and we put YL, which is actually gives the name of alkali group. But what is an alkali group? Normally, in an alkali group, we lack a hydrogen atom. We lack a hydrogen what? Atom. Like, for example, let's take an example here. If you look at our alkali groups here, we have alkali group which is methyl, because it has one carbon atom, but again, it has no hydrogen. Then when we have two carbon atoms, we say ethyl, meaning again it is lacking one what? Hydrogen. Then we have propyl, we have also isopropyl. We also have here, we have what we are calling isopropyl. Isopropyl is somehow branched. That's why we say it is secondary. Then we have butyl, lacking one hydrogen. Then isobutyl, secondary. Then we have that butyl. That butyl, we can try to represent it here on our blackboard, where we have, you can look at your blackboard and see, we have here CH3, that is what we are calling that what? That butyl. So these are some of the names of our alkaline what? Groups. So we are going to use these names in naming straight chain what? Alkanes. So we are going to say naming actually branched alkanes, not straight chain alkanes. Branched alkanes can be named basing on some of these rules laid down by the IUPAC system, or we call the systematic way of naming. So branched alkanes are named basing on the following rules. The first thing we normally do here, we choose the longest possible chain, or we select the longest possible chain. So if you have an organic compound, the first thing you do, you choose the longest possible chain. Then number the carbon atoms, giving the branched carbon atom the lowest number possible. Then when writing alkali groups, numbers are added to show their position in the carbon what? Chain. Yes. So if we have two or more similar alkali groups, the following prefixes are used: di, tri, tetra, penta, and hexa. Then the name of the alkali groups are supposed to be written in alphabetical order. Then we also carry out punctuation by using commas, a hyphen. If you're separating the numbers and you use a comma. If you're separating numbers and words, use a what? Hyphen. The names of alkali groups are written first, followed by the name of the longest possible chain. Then we have examples here. So we are going to look at different what? Examples. So now you can look at your blackboard. We have here an example. So we are going to use some of those rules to name some of these organic what? Compounds. So supposing we have such an organic compound. So we have, this is a branched organic what? Compound. So the first thing we normally do, as we have said, we choose the longest possible chain containing very many, or the highest number of carbon what? Atoms. Then you give numbers. You give what? Numbers. Normally, we give numbers from left to right. left to right, and right to what? Left. So we can also say 1, 2, 3, 4, 5. Giving the branched carbon atom the lowest number possible, meaning this one has the lowest. So we are going to move from here to here. Why? Because our branched carbon atom has position number 2, unlike here where it has position number 4. So if you are giving the name of this organic compound, we shall say 2-methyl, 2 what? Methyl, and the name of the longest possible chain is what? Is pentane. Pentane, yeah, 2-methyl what? Pentane. And normally when you're writing, we make sure it is written as one name, one word, or joined together. Then again, let's take another example. Supposing now we have something like this. So we are going to give different examples. I'm going to give different what? Examples. So here we say we choose the longest possible chain again. Choose the longest possible what? Chain. Then we say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So every side is position number 3. So we shall say 3-methyl pentane. 3-methyl what? Pentane. So we are moving. So the name of our alkali group is methyl. That's why we say 3 what? Methyl. And this methyl group is on position number 3 in our carbon what? Chain. So supposing now, if you look at our part of our rules number 4. Rules number what? 4. Supposing now we have 2 of them. If we have 2, if we have what? 2 similar ones. 2 similar ones. If you have 2 similar ones. So we have that one, even have this one, they are the same. So we have here, hope you are enjoying our lesson. We are not boring you. 1, 2, 3, 4, 5, 6. So we said according to our rules, we choose the longest possible chain. Choose the longest possible chain. Then giving the branched carbon atom the lowest number possible. So we say 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So you see, if we move from here to here, we have 3, 5, 4, 5. Here we have 2, 3. So we are going to choose where we have 2 what? 2, 3. So we are going to say 2. Then we put, because we have 2 numbers, we put a comma according to our rules. Then we put a dash separating numbers from letters. So there are 2, and then we say di. Di what? Methyl. Dimethyl. Then we say the name of the longest possible chain, which is what? Hexane. Which is hexane, yeah. So our rules, we are trying to modify them in such a way that we can be able to name very well. So now we are also going to continue with our naming. Supposing now we have 2 different alkali groups. If you have CH3, have CH2 and C, then we have here CH2, CH3. Then we have CH2, CH what? 3, and CH2, CH2, CH what? 3. So here we say we're going to label, we choose the longest possible chain. So supposing we have this one. So this is our longest possible what? Chain. Longest possible chain. So in our longest possible chain, we are going to give numbers. We are going to give number 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 6, 7, what? 8. So our longest possible chain has 8 carbon atoms, meaning our main chain is octane. Then we have 2 alkali groups. One of them is ethyl, another one is what? Methyl. So, but we're going to give the branch carbon atom the least position. So we have 3, 5, and we have 4, 6. So 3, 5 is better. So we are going to move like this. So we say ethyl and methyl, which one is first in alphabetical what? Order. In alphabetical order, we begin with E. So we shall say 3 what? 3 ethyl. 3 what? Ethyl. Then 5 what? Methyl. So you separate using those hyphens. Then octane. Okay, 10. So let's continue again. So we have seen the rule of alphabetical order. So how does this rule of alphabetical order work when we have these dies and tries? Like for example, if I have these 3 here, and I have CH2, I have CH, I have CH2, CH2, CH3, I have CH2, I have CH2, CH3. I can also have CH2, CH2, and CH what? 3. So sorry for that. So you see, now we are going to choose the longest possible chain. This is our longest possible chain. Longest possible what? Chain. So then after we label the carbon atoms, we say 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. So giving the branched carbon atom the lowest number possible. So we have 4, 6, 8, and the 2, 4, 6. Yeah, the best one is 2, 4, 6. Even if you add the numbers, you'll observe that 2, 4, 6 is smaller. Then after we are going to say alphabetical order we don't consider the dyes. We don't consider the dyes. So we have methyl, ethyl, and the propyl. So which one is first in alphabetical order? It is what? Ethyl. So because we are moving from here to here, we shall say 6 what? Ethyl. 6 what? Ethyl. Then the P and M. You can say A, B, C, D, E, F, D, H, I. So which one is first? Is M. So we say here we have 2 di what? Dimethyl. Dimethyl. So they are 2 and they are similar. Then we have on position number 4. Position number 4. We say 4 what? 4 propyl. 4 propyl. So we have E, M, P. The numbers don't matter. Then the name of the longest possible chain, which is what? Nonane. Which is what? Nonane. So we have included the alphabetical order. We have also included the dyes. Also, we have seen. So we are going to have also another example. Another what? Example. So supposing we have an example which is a very long chain here, where we can say CH3, CH2, CH2, CH what? 3. Then we have CH2, CH3, CH2, CH what? 3. Then we have also C here, H, So we are talking about alkanes. Alkanes. So we have here also CH2, CH2, CH, CH what? And CH2, CH what? So this is our organic compound. And they tell you to name such an organic what? Compound. You see, we have many alkyl what? Groups. Have many alkyl what? Groups. So what we need to first do is to choose the longest possible chain. So what's the longest possible chain? We are going to have these. The one which has the highest number of carbon what? Atoms. Number of carbon what? Atoms. So this will be our longest possible chain. Then we are going to label the carbon atoms. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and what? 12. So let's check and see again. We can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our angle is dodecane is the longest possible chain. So when you move like this to here, here we have the one which has the lowest branch is 3. And then when you move from here, it is what? 4. So we say 4, 4, 6. Here we have 2, 5. So you see? 2, 5. You see what we have? So I'm going to move like this. Let me do it very quickly. So identify the alkali groups. We have methyl, we have ethyl, we have ethyl, we have methyl, methyl. So how many methyls do we have? 1, 2, 3. 1, 2, what? 3. Then ethyl we have 2. So ethyl we are going to use ethyl. Ethyl we are going to use, let me see. We said we are going to move like this. So 6, 5. So we can say 5 what? 5, 6, di what? Di ethyl. Di what? Ethyl. 5, 6, di ethyl. Then we say 3, 7, 3, 7, 9, try what? Trimethyl. Trimethyl dodecane. The what? Decane. So hope you followed that one. Hope you followed it. And you've learned how to name. It's just revision because we have covered it once, but it's good for you to be sure about our naming. So you try out also this example. Try out that what? Example. Make sure you get the name. Make sure you get the name. Give the name of the following organic what? Compound. What we are sure of that this compound is an alkane. An what? Alkane. So what the first thing we have seen in our rules, you choose the longest possible chain. Choose the longest possible chain. So I see our longest possible chain here is having like 9 carbon atoms. So you look at it. You look at it. Thank you very much for following me today. Hope you have enjoyed our lesson. It was I know it was quite interesting. It was quite interesting. So make sure you try out the work we have left you with, and you become an expert in naming. God bless you very much. See you next time.